The night sky above Earth had always been a place of silent permanence. For countless generations, humanity had looked upward to find an unchanging backdrop, a celestial canvas scattered with the same ancient constellations, their slow drift imperceptible on the scale of human life. The stars were our constants, the cosmic clock by which civilizations had measured time, planted crops, and told stories. But permanence in the universe is an illusion. Even the most fixed points are in motion, and even the most tranquil heavens can conceal unimaginable dangers moving silently toward us. It began without spectacle, without the kind of dramatic warning a Hollywood script might demand. No bright flash in the sky, no sudden wave of radio chatter from startled astronomers. Somewhere, far beyond the orbit of Pluto, a presence stirred in the darkness, a point of gravity, invisible and silent, carrying with it the warping of space and time itself. The black hole was small by cosmic standards, its mass perhaps only a few times that of our sun, compacted into a sphere no wider than a city. But mass is not judged by size, and in the language of the cosmos, it was a predator moving through the dark ocean of space. At first, its approach was masked by the sheer emptiness between the stars. Black holes are, by their nature, hidden from direct sight. They emit no light, they swallow it. No telescope, no matter how powerful, could catch its shape against the blackness. But the universe has a way of betraying even its most secretive denizens. As the object moved through the interstellar medium, its immense gravity began bending the light of background stars, distorting them into faint arcs. To a trained observer, somewhere in a darkened observatory on Earth, these subtle signatures would be a whisper of warning. Gravitational lensing, the telltale ripple of an unseen mass. It was not the first time astronomers had caught such patterns. In 1919, during a total solar eclipse, Sir Arthur Eddington had famously measured the deflection of starlight by the sun's gravity, proving Einstein's theory of general relativity correct. Back then, the distortion had been tiny, a fraction of a degree. But here, in the depths of space, the lensing was stronger, sharper. Some background stars seemed to sway in slow, impossible arcs, their light bent by a moving mass with frightening density. In scientific circles, there is a phrase for such a discovery: a candidate, a possible explanation. At first, some believed it might be a wandering brown dwarf, a failed star roaming the galaxy. Others suggested an ultra-dark cometary cloud, a cluster of invisible mass. But with every new observation, the data narrowed, and an unsettling conclusion began to take shape. The gravitational signature matched that of a black hole, and its motion implied it was on a trajectory leading it closer to the solar system. Still, the early calculations placed it decades, even centuries away. The public would not hear about it, not yet. In the quiet rooms of space agencies and research institutes, however, computer models began to run, simulating its approach. Its velocity was high, its path unaltered by any nearby massive objects. There would be no chance encounter to divert it. For now, it was nothing more than a ghost in the night, but one with a destination. On Earth, life continued in the rhythms it had always known. The hum of cities, the slow drift of seasons, the ordinary business of survival. High above the atmosphere, satellites traced their orbits, beaming down weather forecasts, navigation signals, and images of our blue and green world. In the deep sky beyond them, the Voyager probes, humanity's oldest emissaries to the stars, drifted outward, their instruments long silent, their gold records still waiting for someone or something to find them. Unaware, they sailed through the void, toward the same darkness from which the intruder came. To imagine the black hole's journey is to imagine an object utterly indifferent to the concepts of destination or consequence. It moves because gravity has set it in motion, because some ancient encounter millions of years ago nudged it onto this path. Perhaps it once circled a star, its orbit stable, until a close pass with another massive body flung it free. Perhaps it was born from the collapse of a massive star in some forgotten corner of the galaxy, a supernova so distant that its light never reached our eyes. Now it is nothing more than momentum and gravity, a traveler through the Milky Way's spiral arm. The space it passes through is not truly empty. Here and there, clouds of interstellar gas drift like cosmic fog banks, thin enough that a cubic kilometer might contain only a handful of atoms. The black hole passes through these unseen mists without slowing, but as it does, it leaves faint traces, the heating of gas as it falls inward, the occasional X-ray flare from a captured particle spiraling down into its event horizon. Sensitive instruments like NASA's Chandra X-ray Observatory can detect such signatures only if they know where to look. In this case, there was no warning, no reason to aim at that patch of sky, not until the distortions in starlight began to tell their story. Even then, human perception of cosmic time is deceptive. The black hole's approach is slow enough that it would take years before its presence would grow undeniable. But those years are nothing in astronomical terms. And once it begins to influence the architecture of our solar system, once its gravity starts to tug at the delicate orbits of distant icy bodies in the Kuiper Belt, the changes will accelerate. The planets, so stable in their clockwork dance for billions of years, will find themselves subtly pushed, their orbital paths twisted in ways they have never experienced before. But for now, the world sleeps under familiar stars. The oceans move with the pull of the moon, the continents shift imperceptibly under tectonic forces, and the great weather systems of Earth churn and dissipate as they always have. But above it all, in the deep black where the sun's light fades into nothing, a shadow without shape is drawing nearer. And if we could stand far enough away to watch, to see the solar system from the cold vantage point of interstellar space, we would notice the tiniest of tremors in the pattern, a subtle tightening, as though the very fabric of the system is bracing for something it cannot yet name. The night sky above Earth had always been a place of silent permanence. For countless generations, humanity had looked upward to find an unchanging backdrop, a celestial canvas scattered with the same ancient constellations, their slow drift imperceptible on the scale of human life. The stars were our constants, the cosmic clock by which civilizations had measured time, planted crops, and told stories. But permanence in the universe is an illusion. Even the most fixed points are in motion, and even the most tranquil heavens can conceal unimaginable dangers moving silently toward us. It began without spectacle, without the kind of dramatic warning a Hollywood script might demand. No bright flash in the sky, no sudden wave of radio chatter from startled astronomers. Somewhere, far beyond the orbit of Pluto, a presence stirred in the darkness, a point of gravity, invisible and silent, carrying with it the warping of space and time itself. The black hole was small by cosmic standards, its mass perhaps only a few times that of our sun, compacted into a sphere no wider than a city. But mass is not judged by size, and in the language of the cosmos, it was a predator moving through the dark ocean of space. At first, its approach was masked by the sheer emptiness between the stars. Black holes are, by their nature, hidden from direct sight. They emit no light, they swallow it. No telescope, no matter how powerful, could catch its shape against the blackness. But the universe has a way of betraying even its most secretive denizens. As the object moved through the interstellar medium, its immense gravity began bending the light of background stars, distorting them into faint arcs. To a trained observer, somewhere in a darkened observatory on Earth, these subtle signatures would be a whisper of warning. Gravitational lensing, the telltale ripple of an unseen mass. It was not the first time astronomers had caught such patterns. In 1919, during a total solar eclipse, Sir Arthur Eddington had famously measured the deflection of starlight by the sun's gravity, proving Einstein's theory of general relativity correct. Back then, the distortion had been tiny, a fraction of a degree. But here, in the depths of space, the lensing was stronger, sharper. Some background stars seemed to sway in slow, impossible arcs, their light bent by a moving mass with frightening density. In scientific circles, there is a phrase for such a discovery: a candidate, a possible explanation. At first, some believed it might be a wandering brown dwarf, a failed star roaming the galaxy. Others suggested an ultra-dark cometary cloud, a cluster of invisible mass. But with every new observation, the data narrowed, and an unsettling conclusion began to take shape. The gravitational signature matched that of a black hole, and its motion implied it was on a trajectory leading it closer to the solar system. Still, the early calculations placed it decades, even centuries away. The public would not hear about it, not yet. In the quiet rooms of space agencies and research institutes, however, computer models began to run, simulating its approach. Its velocity was high, its path unaltered by any nearby massive objects. There would be no chance encounter to divert it. For now, it was nothing more than a ghost in the night, but one with a destination. On Earth, life continued in the rhythms it had always known. The hum of cities, the slow drift of seasons, the ordinary business of survival. High above the atmosphere, satellites traced their orbits, beaming down weather forecasts, navigation signals, and images of our blue and green world. In the deep sky beyond them, the Voyager probes, humanity's oldest emissaries to the stars, drifted outward, their instruments long silent, their gold records still waiting for someone or something to find them. Unaware, they sailed through the void, toward the same darkness from which the intruder came. To imagine the black hole's journey is to imagine an object utterly indifferent to the concepts of destination or consequence. It moves because gravity has set it in motion, because some ancient encounter millions of years ago nudged it onto this path. Perhaps it once circled a star, its orbit stable, until a close pass with another massive body flung it free. Perhaps it was born from the collapse of a massive star in some forgotten corner of the galaxy, a supernova so distant that its light never reached our eyes. Now it is nothing more than momentum and gravity, a traveler through the Milky Way's spiral arm. The space it passes through is not truly empty. Here and there, clouds of interstellar gas drift like cosmic fog banks, thin enough that a cubic kilometer might contain only a handful of atoms. The black hole passes through these unseen mists without slowing, but as it does, it leaves faint traces, the heating of gas as it falls inward, the occasional X-ray flare from a captured particle spiraling down into its event horizon. Sensitive instruments like NASA's Chandra X-ray Observatory can detect such signatures only if they know where to look. In this case, there was no warning, no reason to aim at that patch of sky, not until the distortions in starlight began to tell their story. Even then, human perception of cosmic time is deceptive. The black hole's approach is slow enough that it would take years before its presence would grow undeniable. But those years are nothing in astronomical terms. And once it begins to influence the architecture of our solar system, once its gravity starts to tug at the delicate orbits of distant icy bodies in the Kuiper Belt, the changes will accelerate. The planets, so stable in their clockwork dance for billions of years, will find themselves subtly pushed, their orbital paths twisted in ways they have never experienced before. But for now, the world sleeps under familiar stars. The oceans move with the pull of the moon, the continents shift imperceptibly under tectonic forces, and the great weather systems of Earth churn and dissipate as they always have. But above it all, In the deep black where the sun's light fades into nothing, a shadow without shape is drawing nearer. And if we could stand far enough away to watch, to see the solar system from the cold vantage point of interstellar space, we would notice the tiniest of tremors in the pattern, a subtle tightening, as though the very fabric of the system is bracing for something it cannot yet name. The announcement did not come with the drama of a breaking news bulletin. It was not the stuff of cinematic countdowns or sirens in the streets. Instead, it arrived quietly, folded into the stream of global headlines. A press release issued jointly by several of the world's leading space agencies. The language was precise, measured, and antiseptic, written by committees who knew that every word would be scrutinized. A stellar mass gravitational anomaly, confirmed to be on an intersecting trajectory with the outer solar system, with no immediate risk to Earth, but with potential for significant long-term dynamical effects. To most readers, it was background noise, one more piece of science news competing with political drama, sports, and celebrity gossip. But in scientific and policy circles, the impact was immediate and electric. Journalists scrambled for interviews with astrophysicists, who suddenly found themselves speaking on camera to audiences far larger than they were used to. Terms like event horizon, space-time curvature, and tidal forces began slipping into primetime news, often mangled in translation, stripped of nuance, yet carrying an undeniable weight. The first images released to the public were underwhelming to the untrained eye, a faint scattering of stars subtly warped into arcs. But the accompanying simulations, glowing digital renderings of a black sphere surrounded by a halo of distorted starlight, ignited the imagination. In living rooms around the world, people watched graphics of a black hole moving inexorably toward the solar system, the planet's orbits bending in slow, graceful arcs before flickering out of alignment. Governments reacted in varying degrees of seriousness. Some quietly funded emergency research initiatives, funneling resources into observatories, high-performance computing, and new deep space probes. Others, wary of alarming their populations, downplayed the urgency. In authoritarian states, the news was barely mentioned at all, filtered to avoid speculation that could undermine stability. Yet even in countries where the information was public, the enormity of the concept eluded most people. A danger that might unfold over decades or centuries was easy to set aside in a world that measured threats in quarterly reports and election cycles. But for scientists, however, there was no comfort in distance. Even at this stage, with a black hole still far beyond Neptune's orbit, the mathematics of its influence was sobering. Models suggested it would pass close enough to the Oort cloud to scatter vast numbers of icy bodies inward. The result would be a slow, relentless hailstorm of comets, some harmlessly vaporizing in the sun's heat, others plunging deep toward the inner planets. Impacts on Earth might be centuries away, but once set in motion, the chain reaction could not be reversed. New projects sprang into existence almost overnight. NASA and the European Space Agency proposed twin deep space probes, each designed to intercept the black hole's projected path decades in advance. These would carry the most sensitive instruments ever launched: gravitational wave detectors, particle analyzers, and arrays of high-resolution cameras capable of capturing indirect glimpses of the black hole's accretion effects. The mission names were suitably dramatic: Aegis and Nix. China, Russia, and India announced their own competing missions, each aiming to claim a first in the history of space exploration, the direct study of a rogue black hole. Meanwhile, amateur astronomers, the quiet, patient sentinels of the night, began to detect its passage for themselves, Equipped with advanced CCD cameras and access to shared data repositories, they could track the distortion of background stars over weeks and months, uploading their findings to online forums where professionals lurked under pseudonyms. The thrill of discovery was tempered by a creeping unease. Some of these observers, knowing how to read the data, realized the true implications well before any government statement admitted them. As months passed, the black hole's presence began to register not just in telescopes, but in the motions of our own solar system's inhabitants. The orbits of a few distant trans-Neptunian objects shifted measurably. One long-period comet, catalogued centuries ago, began arriving months ahead of schedule, its path subtly bent. Nothing catastrophic yet, just the first quiet touches of a gravity weld the size of a city, 100 times more massive than Earth, feeling for us across the dark. It was in those same months that a subtle change began to take place in human culture. The black hole entered art, literature, music. Poets wrote of it as a dark star, a mouth of the night, a cold god on a long pilgrimage. Painters depicted Earth as a fragile glass orb floating toward a silent whirlpool. Filmmakers seized on the imagery, producing speculative dramas and documentaries that blurred the line between science and myth. In online communities, conspiracy theories bloomed, some claiming the black hole was artificial, the work of an alien civilization. Others insisted governments were hiding its true arrival date, or that it was somehow connected to the warming climate, the rise in earthquakes, even personal misfortunes. Through it all, the object itself remained what it had always been, utterly silent, invisible except for the way it bent the light of things behind it. A singularity wrapped in a cloak of absence. And yet, if one could somehow drift alongside it in the endless dark, one would see not nothingness, but a place where the laws of reality began to stretch thin. Dust and stray particles caught in its influence would spiral inward, glowing faintly as they accelerated to near light speed before vanishing. Behind it, the stars would twist into impossible shapes, arcs of light curving across a backdrop of black so deep it seemed like a hole torn in the fabric of existence. On Earth, the research continued in feverish cycles. The questions grew sharper. How close would it pass? What velocity? Would the sun's gravity deflect it even slightly, or would it remain unperturbed, a predator ignoring the flailing of its prey? Every new dataset offered clarity and yet deepened the sense of inevitability. This was not a danger that could be deflected by rockets or shields. The only constant was the ticking of a cosmic clock, counting down not to impact, but to transformation. And in the cold silence between the planets, that transformation was already beginning. It began subtly, almost imperceptibly, but once noticed, it could no longer be ignored. At first, it was the astronomers who saw it, in the long, meticulous records comparing star charts from decades past. The planets were drifting, not by much, just fractions of a degree in their orbital positions, shifts so small they could be mistaken for measurement errors. But these errors persisted, and they grew. The solar system's great clockwork, whose precision had been mapped and verified over centuries, was losing its perfect rhythm. Neptune felt it first. Its slow march around the sun had been minutely altered, its speed varying in a way no gravitational influence from known planets could explain. Uranus followed, its orbital path subtly stretched as though some invisible hand were tugging at it from the dark. Deep in the scattered disk, icy bodies that had circled the sun for billions of years were breaking rank, their orbits twisting into new, unpredictable shapes. At the same time, cometary activity began to rise. A handful of faint, ancient comets, objects that had slumbered for millennia in the frozen vault of the Oort cloud, were now on paths bringing them inward. Most were too small to be seen without large telescopes, and their arrival caused no alarm beyond observatory walls. But to those tracking them, the pattern was clear. They were not random visitors. They had been dislodged. Something massive, far out in the dark, was stirring the deep reservoirs of the solar system like a hand swirling the surface of a still pond. Then came the flare. It was not visible to the human eye, but space-based X-ray observatories detected it instantly, a brief, sharp spike of radiation from the coordinates of the approaching anomaly. To those who understood what it meant, the message was unambiguous. The black hole had fed. Somewhere in the outer darkness, a fragment of matter, perhaps a stray rock, perhaps a small comet, had wandered too close and crossed the point of no return. As it fell inward, spiraling at near light speed, it heated to millions of degrees, releasing a burst of energy before vanishing forever into the singularity. It was the first direct signature, the first tangible proof that what was coming was not hypothetical. Public attention began to turn in earnest. News anchors, once content to treat the story as a curiosity, now spoke in tones of measured gravity. The animations grew more sophisticated, showing not just a drifting black sphere, but its invisible sphere of influence stretching millions of kilometers. Artists rendered the black hole's passage through the Oort cloud as a glittering cascade of icy bodies, some hurtling toward the sun like thrown knives. The phrase gravitational tide began to appear in headlines, a poetic but deadly accurate description of what was happening. In response, the Aegis and Nix missions accelerated their timelines. Construction crews at launch facilities worked under floodlights through the night. The probes would be humanity's only chance to study the black hole up close, to gather data before it passed and carried its secrets back into the void. For scientists, there was an almost morbid excitement, an encounter with one of the universe's most extreme objects, a phenomenon few had dared to hope to see in such proximity. For others, it was less an opportunity than a countdown. By now, the black hole's gravitational footprint was large enough that even amateur astronomers could measure its effects indirectly. Forums and social media lit up with posts from backyard observers plotting the altered paths of minor planets. Some of these hobbyists were skilled enough to run their own orbital simulations, and their projections, shared in grainy late-night videos, sometimes matched those of the world's top observatories with unsettling accuracy. The sense of a shared watchfulness began to grow, a global vigil in which anyone with a telescope and patience could participate. And still, the black hole itself remained unseen. No photograph could reveal its presence. No gleam of light could betray its approach. It was a void moving through the void, known only by the chaos it left in its wake. If one could have traveled there, far beyond the reach of any human craft, the approach would be both magnificent and terrifying. The stars behind it would appear warped into arcs of impossible geometry, while any matter unlucky enough to cross its path would flare and vanish in an instant. The very fabric of space around it would seem to flow inward, as if reality itself was falling. Closer to home, another subtle change began to occur. The Kuiper Belt, that icy ring beyond Neptune, was starting to shift. Astronomers noted a growing asymmetry, a bulge in the distribution of objects, as though the belt itself were being pulled toward a new gravitational center. In ancient myths, sailors spoke of maelstroms in the sea, whirlpools that could drag ships to their doom. Here, on a scale billions of kilometers wide, the solar system was beginning to form one of its own. And somewhere beyond that bulge in the unlit cold, the intruder continued its steady approach. The distance was still vast, but the time remaining before its influence reached the inner planets was no longer measured in centuries. It started with whispers among stargazers, not the seasoned professionals in mountaintop observatories, but the quiet community of hobbyists who spent their nights under dark skies with nothing more than binoculars, star charts, and patience. They were the first to notice that certain constellations no longer looked right. Not wrong in a way you could easily put into words, the stars were all still there after all, but in their alignment, in the way some of them seemed to bend ever so slightly from their familiar positions, as though someone had drawn the heavens on a sheet of glass and was beginning to warp it. Reports trickled into astronomy forums. A faint shimmer here, a tiny displacement there. Many dismissed it as atmospheric refraction or tired eyes. But as weeks passed, the pattern emerged. The distortions moved, slowly but steadily, tracing a path across the same region of the sky, exactly where the black hole's projected location lay. It was no longer something only computers could detect. Ordinary eyes, given the right conditions, could now see the universe bending. Then came the first night of real public astonishment. In a rural community in New Zealand, far from city lights, a group of photographers set up to capture the Milky Way's arc across the winter sky. Reviewing their long exposure shots, they found something eerie. A cluster of stars at the edge of the frame appeared stretched, smeared into faint arcs. It wasn't motion blur. The rest of the stars were razor sharp. The images went viral, and for the first time, millions saw the gravitational fingerprint of the black hole for themselves. Within months, the effect was undeniable. In areas of the world blessed with clear, dark skies, people began making pilgrimages to see the distortion. News crews filmed live segments under the stars, the hosts pointing to the faint shimmering patch like tour guides introducing a celebrity. The black hole had no light, no form, yet it was now a visible feature in the shared human sky, a ghost against the cosmos. But visibility brought something else: fear. It's one thing to know intellectually that a distant object is approaching. It's another to stand beneath the night and watch space itself curve where it passes. The knowledge that nothing, no shield, no fleet, no intervention, could halt it began to seep into the public consciousness. Talk radio filled with anxious speculation. Religious leaders gave sermons interpreting the phenomenon through the lens of prophecy and divine will. Survivalist groups began planning for a future they imagined would be choked with comet impacts or flung into freezing darkness. Meanwhile, the black hole's pull deepened. The growing gravitational tides were now subtly affecting the inner solar system's own rhythms. The orbits of several asteroids in the main belt between Mars and Jupiter shifted just enough to throw off predictions used by planetary defense programs. The adjustments were small, but they were proof that the reach of this intruder had crossed another threshold. Astronomers at planetary defense conferences began speaking in sharper tones, their presentations tinged with urgency. Space agencies released updated simulations, interactive maps the public could manipulate, zooming from the grand sweep of the solar system down to Earth itself. In some models, the black hole passed at a safe distance, leaving our planet's orbit mostly intact but triggering an era of heightened cometary bombardment. In others, the pass was closer, dragging Earth slightly outward from the Sun and plunging it into a prolonged ice age. The models never promised certainty. They offered only a menu of fates, each governed by the indifferent laws of gravity. And yet, for all the talk of disaster, a quieter truth spread among scientists. This would be the single greatest scientific opportunity in the history of the species. Missions were now not just proposed, but greenlit and funded at a breakneck pace. The Aegis and Nix probes were ahead of schedule, their instrumentation refined to unprecedented sensitivity. Other nations began constructing gravitational wave detectors in orbit, hoping to pick up the faint ripples generated by the black hole's movements. A flotilla of small robotic craft was planned, swarms of sensors that could be cast ahead of the black hole to be swallowed, transmitting data until the very last second before falling into oblivion. The first scheduled launch came under a flawless morning sky at Cape Canaveral. Cameras captured the moment the rocket lifted into the blue, carrying Aegis on the start of its long, cold pursuit. There was applause in the mission control room, but the celebrations were subdued. Everyone understood that by the time Aegis reached its quarry, the black hole would already be far closer to home. That same night, a new sight appeared in the heavens, faint but impossible to explain away. A tiny point of X-ray light flickering intermittently from the direction of the black hole. Astronomers knew what it meant. More debris was falling in, heating as it spiraled toward the event horizon. The meal was irregular, just scraps from the dark, but each flare was a warning. The void was awake, and it was hungry. On Earth, the airwaves filled with images of the distortion patch, now nicknamed the Eye by popular culture. The name was fitting in a way. It seemed to watch us, even as it drew closer. But the black hole had no awareness, no malice. It was only gravity, unthinking and absolute. Still, for those who stood beneath the bending stars, watching the Eye move across the sky, it was hard to believe it didn't somehow see us too. And all the while, the distance closed. The first signs came not from the sky, but from the oceans. At first, the differences were so small that even coastal scientists dismissed them as noise, just another irregularity in the complex dance of tides influenced by the moon, the sun, and local weather systems. But with each lunar cycle, the deviation grew. Tides arrived minutes off schedule. High water marks nudged slightly higher in some regions, lower in others. The changes were inconsistent, uneven, and baffling, until someone began comparing them to the predicted arrival times of the moon itself. It was the orbital ephemerides that told the truth. The moon, the ever-faithful companion of our planet, was fractionally ahead of where it should have been. The difference was infinitesimal, millimeters per second in orbital velocity, but over weeks it compounded. The cause, when traced back through the calculations, was undeniable. Earth's orbit was no longer perfectly unperturbed. Something far away, something unimaginably massive, was tugging at the Earth-Moon system just enough to make the dance falter. While the public marveled at the eye in the night sky, oceanographers and geophysicists began quietly alerting their governments. Even such tiny changes in orbital dynamics could, over years, alter climate patterns. Monsoons might shift in timing. Hurricane seasons might creep earlier or later. Agricultural calendars could slip subtly out of sync with the sun's energy. At first, this sounded like the distant concerns of theoreticians, but nature wastes no time in proving theory correct. By late summer, the jet streams in both hemispheres had begun to wander off their expected courses. Satellite imagery showed patterns in cloud cover that meteorologists had never seen before. Long ridges of high pressure stalled in place for weeks, holding heat waves over some continents and blocking storms from reaching others. It wasn't yet clear whether the black hole's approach was the direct cause. The atmosphere is too chaotic to yield simple answers, but the timing gnawed at those who'd been tracking its progress. The solar system, it seemed, was beginning to feel the first threads of a much larger gravitational tide. And then came the meteoroid. It was small, barely 2 meters across, and it burned up harmlessly over the South Pacific, leaving nothing but a brief streak of light in the upper atmosphere. But when astronomers backtracked its trajectory, they found something astonishing. It had not come from the usual well-mapped corridors of debris that Earth encounters every year. Instead, its path traced outward, far beyond the known asteroid belt, into the regions where cometary bodies slumber in deep freeze. It was a messenger from the disturbed outer system, a single grain shaken loose ahead of the main storm. The discovery triggered a surge of urgency in the planetary defense community. Telescopes already tasked with tracking near-Earth objects were pushed to their limits, scanning for other inbound bodies. What they found was unsettling. A small but noticeable uptick in the number of long-period comets on unusual sunward trajectories. Most posed no threat to Earth, but the fact that they were arriving at all was a signal. The Oort cloud was stirring. The black hole itself remained invisible, but the effects were becoming a constellation of their own. Ripples in the oceans, shifts in the weather, unexpected visitors from deep space. For the first time, the average citizen could look at the news and see cause and effect. The distant shadow in the sky was no longer an abstract problem for scientists to argue over. It was here, in the world of tides and storms and streaks of fire across the night. In response, Aegis and Nix received a wave of public support unprecedented for any space mission. Schools held fundraisers, artists painted murals of the probe streaking toward a black horizon, and governments poured emergency funds into the construction of deep space communication arrays to ensure no second of data would be lost. For perhaps the first time in history, humanity's scientific ambitions were not just about curiosity, they were about self-preservation. Yet there was an irony in it all. The closer the black hole came, the more beautiful the night became. The eye now shimmered with a strange intensity, bending the light of distant stars into arcs so long they looked like the curve of some vast invisible dome. In time-lapse footage, the distortions seemed to swirl, like a galaxy caught in motion. People who had never cared for astronomy found themselves driving into the countryside just to witness it. But beauty has never been a promise of safety, and as the autumn equinox approached, astronomers detected something new, something that made the hair on the back of their necks stand on end. A single faint gravitational wave signal recorded simultaneously by detectors on 3 continents. It was subtle, buried in background noise, but when analyzed, it aligned perfectly with the mass and velocity of the intruder. The black hole was close enough now for its movement to stir the fabric of space itself. It began as a distant uptick in telescope logs, dots of light creeping inward from the darkness beyond Neptune, each following a long, elegant curve toward the sun. Most of them were faint, ancient comets, whose icy surfaces had never felt heat in the history of human civilization. But as they approached, the sunlight began to wake them, turning them into ghostly beacons, vast tails of gas and dust streaming for millions of kilometers. At first they were curiosities. News outlets ran glossy images of these newcomers, treating them as cosmic spectacles. Amateur astronomers posted videos of the comets brightening night by night. Social media made them viral, overlaying dramatic soundtracks on footage of shimmering tails. Yet beneath the surface enthusiasm, the professionals were counting trajectories, calculating perihelion distances, and plotting the odds. Some of these newcomers would miss the inner planets by astronomical margins. Some would not. The first close call came in winter. The object was designated C/Blacktide 1, an improvised name that the press quickly devoured. Discovered only 8 months before perihelion, it was a relatively small comet, less than a kilometer across, but its velocity and path brought it within a hair of intersecting Earth's orbit. In the end, it missed by a comfortable margin of 180,000 kilometers, about half the distance to the Moon. But for weeks, the astronomical community held its breath, and when it finally passed, the relief was public. That close pass broke something in the collective calm. If a comet could come that near with less than a year's warning, what else might be inbound? And how many would arrive together? The answer came faster than expected. Over the next 18 months, long-period comet detections tripled. The Oort cloud, disturbed by the black hole's advance, was shedding debris in waves. Astronomers explained that the gravity well sweeping past the solar system acted like a spoon stirring a pot, not sending everything inward at once, but creating chaotic currents that would ripple for centuries. Some of the bodies pulled sunward now would not arrive for generations, but some were already here, accelerating toward the sun's warmth and Earth's thin atmospheric shield. The sky began to remind us of our vulnerability. On a cold February night, a fireball tore across the Canadian Arctic, brighter than the Moon. It disintegrated high in the atmosphere, but windows rattled in remote towns hundreds of kilometers away. 2 months later, a smaller bolide exploded over the Indian Ocean, scattering fragments into the waves. These were not extinction-scale events, far from it, but they were the front edge of something bigger. Governments responded in ways both bold and desperate. Planetary defense systems that had been hypothetical for decades leapt from design boards into production. The United States and China collaborated on a fleet of kinetic interceptors, massive rockets tipped with inert, high-density projectiles designed to strike comets head-on and nudge them off course. Europe and Japan poured resources into developing laser-based deflection concepts, knowing they were unlikely to be ready in time for the current wave, but essential for the centuries-long hazard to come. For all the engineering optimism, the truth was sobering. Most of these systems could only respond to threats detected years in advance, not months. And in the chaos of disrupted orbits, some comets would not give us that luxury. Through it all, the black hole itself loomed closer, invisible but no longer abstract. The gravitational lensing now dominated a swath of sky large enough to catch the casual gaze of anyone looking up from a dark field. The eye no longer looked like a faint shimmer. It was a warped pool of stars, an area where reality seemed subtly wrong. Photographers began capturing arcs of light so elongated they looked like pieces of some enormous broken ring. And then came the largest flare yet. It arrived without warning, a colossal spike of X-rays and gamma rays from the black hole's coordinates, detected simultaneously by every major space observatory. Something massive, perhaps a wandering asteroid the size of a small moon, had fallen victim to its pull. The burst was so powerful that for a few hours instruments had to be recalibrated, overloaded by the energy. It was the most violent reminder yet that the intruder was not merely a silent distortion in the sky, but an engine of destruction. In the wake of the flare, public opinion shifted again. The black hole was no longer just approaching, it was actively shaping our reality. The comets it had loosed were no longer hypothetical threats, they were visible in the night sky, bright enough for even casual observers to notice. For the first time, cities far from light pollution saw 2, sometimes 3 comets at once, their tails overlapping like celestial brushstrokes. It was beautiful, and it was terrifying. And still, in every calculation, in every simulation run on the planet's most powerful supercomputers, the same truth emerged. The real encounter, the close pass itself, was yet to come. What we are experiencing now was merely the prelude. It began with the seasons. At first, the changes were subtle, spring arriving a week early in parts of the northern hemisphere, autumn lingering longer in the south. Farmers noticed before anyone else. Planting calendars passed down and perfected over generations began to fail. Crops sprouted too soon or too late. Rain came when the ground could not take it. Frost hit fields that should have been safe. Meteorologists, trying to explain the patterns, pointed to altered ocean currents, shifts in jet streams, and unprecedented pressure systems. But behind the jargon, they knew there was another influence at work, one no earthly weather model had ever accounted for. The black hole was no longer merely an astronomical curiosity. Its gravity had reached far enough inward to touch the very balance of Earth's orbit. The change was minute, invisible to the casual eye, but the effect rippled outward. Our planet's year was subtly stretching, not by hours or even minutes, but by fractions of a second that still carried the weight to tilt climates out of harmony. These small drifts compounded with the altered behavior of the moon, tugging at tides in patterns no one could predict with certainty. And then the planets themselves began to show it. Jupiter, the solar system's giant guardian, whose orbit had been mapped with exquisite precision for centuries, was arriving slightly ahead of schedule at key points in its journey. Mars' position shifted enough to require recalibration of every probe and rover in service. Astronomers watching Saturn's rings noticed an inexplicable asymmetry forming, as though the great planet's orbital resonance with its moons was being warped by an external hand. None of these changes threatened life directly, yet, but their visibility was undeniable. In the late-night hours, amateur astronomers began to detect planetary positions that didn't match their own star charts. Apps for skywatching had to be patched monthly to keep up. The solar system's clockwork was no longer perfectly wound, and now everyone could see the gears slipping. Meanwhile, the influx of comets reached a crescendo. That winter, the skies above both hemispheres carried at least one visible comet almost every night. In rural areas with little light pollution, some nights showed as many as 3 or 4 at once, their tails fanning out in different directions. People spoke of the beauty of it, how the heavens seemed alive in a way they never had before, and yet beneath the awe was a growing sense of unease. The comets were not harmless background scenery. For every one that passed at a safe distance, dozens more raced silently through the void, their paths known only to a handful of sleepless astronomers running orbital calculations in the small hours. The world's space agencies began working together in a way that would have been unthinkable only years before. Data flowed between rival nations without filters, shared openly in the desperate calculus of survival. The Aegis probe, now well beyond the orbit of Pluto, was closing on the outer fringes of the black hole's gravitational well. Its instruments returned strange readings, ripples in the local curvature of space-time, as if invisible waves were moving ahead of the object itself. Tiny fluctuations in the probe's atomic clocks confirmed what theorists had predicted. Time itself was already slowing for Aegis relative to Earth. The black hole was still years away from its closest approach, yet its presence was bending the flow of seconds. Public perception shifted again when a comet, designated C Black Tide 7, became the brightest in living memory. It passed within 20 million kilometers of Earth, visible even from brightly lit city streets, its tail stretching across a quarter of the sky. News coverage was breathless, but in control rooms, the mood was tense. The comet had been discovered only 6 months before perihelion. Had its path been slightly different, there would have been no time to stop it. Climate instability deepened. The Atlantic hurricane season roared with a ferocity never before recorded, its storms lingering for weeks over warm waters that refused to cool. In the Pacific, typhoons veered into unusual latitudes, striking regions unprepared for such violence. Inland, droughts bit harder. Winters swung between unseasonable warmth and sudden brutal freezes. These were not the apocalyptic weather events of disaster films, not yet, but they were loud enough to reach every dinner table, every news feed. And somewhere in the back of the public's mind was the understanding, whether spoken or not, that all of this was connected to the silent thing in the sky. In some places, the fear turned ritualistic. Communities began holding night watches, gathering to stand beneath the warping stars and acknowledge the eye as it crept across the constellations. In others, the anxiety turned inward to survivalism and hoarding. There were voices in politics calling for preparing underground bunkers, stockpiling food for decades, even building arcs in orbit, not to escape the black hole itself, but the long shadow of its aftereffects. The scientists had a different priority: timing. The window for the black hole's closest approach was narrowing. For years, predictions carried uncertainties of decades, but now with new data, those uncertainties collapsed into a handful of years. The encounter would not happen in some remote future. It would happen within the lifetime of every living adult on Earth. And even as the numbers grew more precise, the final figure, its exact distance at closest approach, danced at the edge of their equations like a mirage. Too far, and Earth might survive with nothing worse than a permanent shift in its seasons and a millennium of comet storms. Too close, and our orbit could be stretched just enough to break the stability of our climate entirely. And the black hole continued to fall toward us as it had for millions of years, indifferent to every calculation, every sleepless night, every human hope. Aegis had been coasting through darkness for nearly a decade when its instruments began to twitch with excitement. At first, it was only the subtle things, a faint drift in trajectory that required constant course corrections, a steady increase in background radiation from high-energy particles flung out of the black hole's surrounding environment. But then came the first images, not of the black hole itself, which still remained perfectly invisible, but of what its presence was doing to the light around it. From its distant vantage point, Aegis's cameras captured background stars bending in long, graceful arcs, their colors smeared into subtle rainbows by the extreme warping of space-time. The distortion was sharper here than anything seen from Earth, as if the spacecraft had crossed an invisible threshold, where the universe's geometry began to buckle under the strain. A few weeks later, something new appeared in the data, a flickering point of light in infrared, moving unpredictably near the black hole's projected location. The object was quickly identified as a rogue asteroid, hundreds of kilometers wide, spiraling inward along a doomed trajectory. Aegis's instruments tracked it relentlessly, the flicker growing brighter as tidal forces began to tear it apart. When the final plunge came, the cameras captured a burst of light so intense that it overexposed the sensors, flooding the feed with white before fading back to black. That was the moment the scientists knew they were witnessing something humanity had only ever imagined, a death spiral into a singularity. Matter shredded, accelerated, and annihilated at the edge of the event horizon, releasing more energy in seconds than our sun emits in weeks. The accretion flare that followed was a thing of terrible beauty, a ring of fire that seemed to hover in nothingness, its light warped into a perfect halo by gravity so strong it bent the very paths of photons. When the first processed images reached Earth, they spread across the globe in hours. The pictures were nothing like the smooth, simulated renderings that had filled textbooks for decades. The halo was chaotic, shifting, its colors blending from blinding white to deep crimson. Jets of high-energy particles speared outward in opposite directions, visible even to Aegis's modest sensors, moving at speeds that defy human intuition. Around it all was darkness so deep, so absolute, it seemed like an absence cut into the universe. The public reaction was instantaneous: awe, fear, disbelief. It was no longer an abstract threat in a distant corner of the sky. It was real, tangible, a predator whose face we had finally seen. On the scientific front, the data was a goldmine. Measurements of the gravitational redshift confirmed the black hole's mass and spin with unprecedented precision. Its event horizon radius was calculated down to a handful of meters. For theorists, it was as though a myth had stepped into daylight, every detail sharper and stranger than expected. But one number drew the most attention: its velocity relative to the solar system. The updated figure was slightly higher than earlier estimates, and that meant its passage would come sooner than predicted. On Earth, the changes were no longer deniable. The shifting climate was now joined by a faint but measurable drift in the length of the year. A fraction of a second here, a fraction there, but in the language of orbital mechanics, these were the drumbeats of a system under strain. Satellites in geosynchronous orbit had to be nudged more often to keep their positions. GPS networks recalibrated daily. Astronomers tracking Earth's path against distant quasars could see the wobble in their own data. The black hole's comet storm intensified. Aegis's deep space monitors were picking up dozens of new bodies every month, their orbits chaotic, some crossing the paths of the inner planets. Even as interceptors launched to nudge them aside, it became clear that some would slip through. In the next 5 years, Earth could expect impacts in the tens of megaton range, not civilization ending, but enough to devastate a region or plunge the world into temporary climatic shocks. And through all of this, Aegis kept going. Each day, the images grew stranger. The gravitational lensing from this distance made the surrounding stars appear to flow like liquid, their positions drifting in impossible loops. Time delay measurements from onboard clocks showed that the probe's seconds were stretching compared to Earth's, a slow crawl into the edge of the abyss. In one particularly haunting sequence of images, Aegis caught the ghostly arc of a distant galaxy, its spiral arms distorted into an almost perfect circle around the black hole, a cosmic mirror curved into the shape of eternity. It was then that the mission controllers made a decision. Aegis would dive closer, not to the point of destruction, not yet, but far enough to send back the highest resolution imagery of the accretion halo ever attempted. The maneuver was approved, its trajectory locked in. The probe's tiny thrusters fired, and somewhere in the darkness between the planets and the black hole, a machine the size of a small car adjusted its path toward history. On the night the dive began, people around the world gathered under the distorted stars. They watched the eye swell slowly larger in the sky, its warping now visible even to casual observers. For them, the moment was personal. The machine out there in the void was carrying their gaze into the mouth of the most extreme thing in nature. And in just a few years, that same mouth would pass close enough to alter the fate of their world forever.
The dive began in silence. Aegis, drifting for years on its lonely trajectory, angled itself toward the void and fired its thrusters in short, deliberate bursts. No human hand guided it directly now. The light-time delay between Earth and the probe was too great. Instead, preloaded instructions, written months in advance, unfurled like a mechanical instinct. The tiny spacecraft adjusted its solar panels, pointed its high-gain antenna home, and aimed its instruments toward the most dangerous place it would ever see. For days, it coasted deeper into the black hole's gravitational well. The telemetry scrolling across monitors on Earth began to change, subtly at first, then in ways that made even veteran scientists lean forward in their chairs. The probe's atomic clocks, so stable they could measure the tick of a second within a billionth, were slowing relative to their counterparts on Earth. It was not malfunction, it was the universe itself. Time, in Aegis's frame of reference, was stretching. Every photon it sent home was climbing uphill against gravity so fierce it bent the very metric of space-time. The first images came through distorted, not by equipment error, but by reality itself. Stars bent into full circles around an empty heart. The accretion halo, once a dim blur from afar, now filled the frame, a roiling, luminous ring of gas and dust whipping around the event horizon at nearly the speed of light. Bright knots flared unpredictably as clumps of matter smashed into one another, heating to millions of degrees before vanishing over the edge. Behind it, the background stars were smeared into arcs that wrapped all the way around the darkness, as if the black hole were a cosmic lens reflecting the universe back on itself. As Aegis dipped closer, its magnetometers screamed with readings beyond expected limits. A magnetic field, chaotic, tangled, yet unimaginably strong, wrapped the black hole like a living thing. Bursts of high-energy particles streamed outward in narrow jets, invisible to the eye but blinding in radio and X-ray bands. One jet, kilometers wide but stretching for light years, passed so near the probe's path that it fried a secondary sensor array in an instant. Yet Aegis continued, its primary instruments intact, its antenna locked on Earth. Then came the asteroid. It was larger than the one Aegis had seen weeks earlier, perhaps 300 kilometers across, a worldlet flung loose from some long-dead planetary system eons ago. The black hole's tidal forces had caught it, pulling it into a decaying orbit. Aegis's high-speed cameras tracked the object as it spun wildly, fractures opening along its crust. Moments later, the asteroid stretched into a grotesque teardrop shape, then shattered entirely. The fragments spiraled inward, glowing brighter than the sun in Aegis's sensors, before they were swallowed. The flare that followed dwarfed anything yet recorded, a blinding arc of energy that lit the entire accretion disk, scattering radiation into every corner of the spectrum. Even on Earth, satellites registered the pulse. The images hit humanity like a revelation. They were not smooth, serene portrayals of a perfect sphere. They were violent, pure, and unfiltered. The black hole was not a static void, it was a storm, a predator in perpetual motion, consuming whatever dared to approach. For days, the footage looped endlessly on every newsfeed, every broadcast, every handheld screen. It was as if for the first time the species collectively understood what was coming. But Aegis could not linger. Mission planners had set strict limits. If it dipped too far, there would be no escape, no chance to transmit its treasure home. Thrusters fired again, kicking the probe into a slingshot trajectory that would skim the outer edge of the black hole's influence before sending it on a long, looping arc through the outer solar system. Data continued to pour in as Aegis pulled away, the images slowly sharpening as the extreme gravitational distortions weakened. Back on Earth, celebration of the probe's survival was tempered by a hard truth. The updated trajectory data from Aegis's flyby allowed scientists to recalculate the black hole's path with terrifying accuracy. The closest approach would come in just under 9 years, and it would pass closer than even the most pessimistic models had predicted. Already its influence was deepening. Saturn's orbit was shifting measurably on human timescales. Neptune's position required constant correction for spacecraft navigation. Earth's own orbital eccentricity, its deviation from a perfect circle, was drifting faster than any natural cycle could explain. Weather systems grew stranger by the month as seasonal boundaries blurred into unpredictable transitions. The comet influx showed no sign of slowing. Observatories now tracked hundreds of inbound bodies, a few with diameters measured in tens of kilometers. And still, the eye in the sky swelled, its distortion growing so wide that it brushed the edges of neighboring constellations. People in rural areas could trace the warped patch with the naked eye, pointing it out to children with a mix of wonder and dread. It was no longer just part of the night, it was part of human life, a looming shape in every photograph of the stars, every clear evening, every dream. The calm, if it could still be called that, was ending. The final tide was coming in.
It began with a tremor in the orbits, not seismic, not the trembling of Earth's crust, but a deeper, slower shudder in the paths of worlds. For centuries, the motions of the planets had been as predictable as the ticking of a great celestial clock. Now the hands were slipping. Jupiter's path bent fractionally, pulling its moons into tighter, faster arcs. Mars's orbit tilted by a measurable hair, throwing navigational software on its robotic explorers into frantic recalibrations. Even Mercury, locked so tightly in the sun's grip, displayed a whisper of deviation. To most people, these changes were invisible, but to the scientists watching the data streams, the shift was like seeing cracks in a dam. It was not a matter of if the structure would give way, but how soon. The black hole's tidal reach had crossed a threshold. Every mass in the solar system now felt its pull. Not enough to fling planets from their orbits in a single violent motion, but enough to warp the balance they had kept for billions of years. The innermost system wobbled, just slightly. But those tiny variations translated into profound consequences for the fragile stability of Earth's climate, tides, and seasons. The first comet strike came without warning. It was small by cosmic standards, perhaps 400 meters across, but its velocity was astronomical, 30 kilometers per second. It struck the open Pacific, thousands of kilometers from any shore, but the energy release was greater than every nuclear weapon ever detonated on Earth combined. The water column it blasted skyward climbed 30 kilometers into the atmosphere, forming a temporary plume of vapor and debris that satellites captured in exquisite, terrifying detail. The tsunami was smaller than feared, its force dissipating in the vastness of the ocean, but the psychological impact was colossal. Humanity had just taken its first direct hit from the black hole's comet storm. 3 weeks later, another arrived, this one fragmenting in the atmosphere above the Siberian tundra. The explosion flattened hundreds of square kilometers of forest, echoing the Tunguska event of 1908. But this time, there was no mystery about the cause. The black hole's invisible hand had nudged it here, a messenger from the outer darkness. The impacts triggered a global shift in tone. There was no longer any talk of potential danger. The age of watching was over. The age of enduring had begun. Governments accelerated every planetary defense program they had. Kinetic interceptors were launched almost weekly, streaking into the sky on plumes of fire. Some succeeded, shattering incoming comets into harmless clouds of debris. Others failed, missing their targets or striking too late to make a difference. The sky itself was changing. The eye had grown massive in the darkness, a warped lens the size of a clenched fist held at arm's length. In photographs, its distortion encompassed whole star fields, bending them into strange concentric rings. Even in cities drowned by light pollution, it was visible, a faint smear where the constellations refused to align properly. And it was moving faster now, inching across the heavens month by month, an impossible shadow racing towards its closest point. With each passing day, the comets multiplied. Some were beautiful, long-tailed wanderers that passed harmlessly and faded into the void. Others grazed the atmosphere, leaving glowing trails that turned night into false day. Air traffic controllers began rerouting flights to avoid high-altitude dust clouds left in the wake of recent entries. The upper atmosphere grew faintly hazy, a veil of microscopic debris that scattered sunlight into strange halos. On the oceans, mariners began reporting tides that no table could predict, surges that arrived hours early or late, currents that shifted direction without warning. The moon's orbit was drifting in ways no human eye could see, but every coastal community could feel. In some places, old harbors flooded at high tide for the first time in recorded history. In others, water receded so far that piers hung uselessly above empty mud. And still the Aegis probe whispered from the dark, its signal now faint and delayed but still steady. It reported that the black hole's accretion halo had grown brighter, fed by a steady rain of debris ahead of its passage. Each flare was logged, time-stamped, analyzed, a heartbeat in the silence of the void. 9 years once felt like breathing room. Now, with only 6 left, it was nothing. The black hole's approach was no longer an event on the far horizon of time. It was a tide rising against our ankles, inch by inch, too steady to fight and too immense to stop. By the time the next comet flared over the Atlantic, a small one, burning harmlessly in the upper atmosphere, people no longer looked up with awe. They looked up with calculation, measuring distance, speed, and the odds of survival. The stars had ceased to be fixed. The night sky was alive, and in its warped heart, the eye stared back. 3 years. That was the number circled in red ink on every timeline, every briefing, every mission planning board. 3 years until the black hole's closest pass. 3 years until the solar system would endure the most violent reshaping in recorded history. By now, its presence could be felt, not in the way earthquakes or storms are felt, but in the quiet rhythms that had been constant for millennia. Days grew imperceptibly longer, tides ran stranger still, and the seasons lost their anchor. A summer might stretch far past its usual end. Winter storms would arrive like ambushes. Migratory birds began to change their patterns, guided by cues older than humanity itself. Even the bees in some regions shifted the timing of their hive cycles, reacting to a planet that was no longer in perfect sync with the sun. From orbit, the signs were sharper. The moon's distance from Earth, usually creeping outward by a few centimeters per year, began to oscillate. Satellites had to fire their thrusters more often to maintain geosynchronous positions. Deep space probes to Mars and Jupiter were arriving days off schedule unless constant corrections were made. In the data archives of planetary scientists, neat lines of predicted positions began to curl like paper left in heat. On the surface, the comets kept coming. Some arrived with years of warning, giving interceptors time to adjust their courses. Others appeared almost without notice, detected only weeks before they would cross Earth's orbit. The planetary defense network was at full stretch, a constant cycle of launches, tracking, interception, and cleanup. Even with every resource focused on the task, some slipped through. The largest to strike in this period hit the uninhabited deserts of Western Australia, carving a crater 2 kilometers wide and sending shockwaves across half the continent. It was a wound in the Earth visible from orbit, a scar in the ochre land that would remain for ages. In cities, the mood was shifting. The awe and dread of the eye in the sky had given way to normalization. People lived with it the way they lived with the moon, the sun, or the weather, a part of existence, always there. Children born in this decade had never known a night sky without its warped patch of stars. In paintings, on jewelry, in tattoos, the shape of the distortion became an icon, a symbol of the age, equal parts fear and identity. But the scientists never normalized it. In the great observatories of Chile, Hawaii, and the Canary Islands, data poured in showing that the black hole's tidal forces were accelerating changes in planetary motion. Jupiter's massive gravity, which had shielded the inner planets from much of the cometary onslaught, was itself being slightly deflected, allowing some debris streams to slip past its protection. Mars's orbit was drifting toward a new resonance with Earth's, a delicate, dangerous arrangement that could make both worlds more vulnerable to future gravitational disruptions. Then came the event that stripped away the last illusions of stability. It began with faint ripples recorded by the world's gravitational wave detectors, not the distant chirp of colliding black holes billions of light-years away, but a rolling, low-frequency hum emanating from within our own solar system.
The source, the black hole's interaction with a massive, long-period object, likely a dwarf planet, in the Kuiper belt. The encounter did not destroy the object immediately. Instead, tidal forces tore it into a stream of rubble, hurling fragments into wildly different orbits. In the months that followed, telescopes caught sight of dozens of these fragments tumbling sunward. A few crossed the orbit of Neptune, then Uranus. The models were unambiguous. In less than a decade, Earth would pass through at least one of these debris streams. Some of the pieces were small enough to burn harmlessly. Others were not. In response, the final phase of Aegis's mission was initiated. With its primary survey complete, the probe was commanded to adjust its trajectory into a long, sweeping arc that would place it ahead of the black hole's path. It would act as an early warning outpost, measuring space-time distortions and tracking debris in real time as the gravitational tide rose. Deep space antenna networks around Earth and Mars went into continuous operation to catch every whisper from its signal. And still, the eye grew larger. By now, its distortion spanned an area of the sky so broad it could be seen without looking for it. In rural areas under clear air, the distortion was visible as a faint smudge where the stars bent into shallow arcs. On moonless nights, the effect was almost nauseating, as though the sky itself were a lens, and something on the other side was watching. People reacted in ways both strange and human. Couples proposed marriage under the eye, promising to face whatever future came. Poets wrote verses comparing it to a pupil, a wound, a god. Entire music genres arose around it, slow, echoing compositions that seemed to stretch time in imitation of the black hole's pole. But beneath it all was a common truth. No one, not even the most skeptical, doubted that the next 3 years would define the future of the species. And in the cold, dark gulf beyond Pluto, the intruder kept falling toward us, as it had since before humanity was born, utterly indifferent to what we did with the time we had left.
The final year began with the soundless shifting of worlds. In January, astronomers announced that Jupiter's orbital path had deviated by more than 1,000 kilometers from its predicted position, a displacement that, in cosmic terms, was immense. The gas giant's altered gravity well began to scatter some of its Trojan asteroids into new orbits, sending several tumbling toward the inner solar system. Within weeks, fresh cometary threats were cataloged, their arrival times measured not in decades, but in months. Saturn's rings, normally stable over millions of years, began to ripple in strange, spiraling waves. At first, these undulations were subtle, visible only in high-resolution imaging. By March, they were unmistakable, massive arcs of icy debris lifting and twisting as the black hole's distant pole teased the planet's gravitational balance. Neptune's orbit compressed fractionally, Uranus's tilted just enough to break its long-standing equilibrium with its moons. The solar system's clockwork was no longer merely slipping, it was rattling apart. On Earth, the atmosphere responded in ways that defied precedent. The jet streams fractured into wandering currents, looping unpredictably across continents. Winter storms formed over subtropical oceans. Summer heat domes parked themselves over polar regions. Monsoon rains arrived in the wrong hemisphere. Deserts bloomed briefly before withering into dust. The seasons no longer came in sequence, they arrived like shuffled cards, drawn at random by a climate that had lost its rhythm. The comets grew larger. In May, a 3-kilometer-wide body passed within twice the moon's distance, trailing a tail that arced across half the sky. The sight was breathtaking, bright enough to cast shadows at midnight, but the knowledge of its speed and size left an aftertaste of dread. Had its path been altered by a mere fraction of a degree, the Earth would have endured an extinction-level event. Planetary defense interceptors were now launching almost weekly, their bright trails becoming as familiar to the public as jetliners. Some missions succeeded spectacularly, breaking incoming comets into harmless shards. Others missed by seconds, allowing their targets to graze the atmosphere in incandescent fireballs. By mid-summer, the eye was no longer just a distortion in the night sky. It was a dominating presence. From horizon to horizon, the stars within its warped region stretched and curved, some looping into near-complete arcs. Photographers could no longer capture the constellations without their shapes appearing wrong. To look at the eye too long was to feel a strange disorientation, as though gravity itself were steadily pressing in on the observer. In August, Aegis reported its most startling data yet. It had crossed into a region where gravitational gradients changed over distances of mere kilometers, causing subtle flexing in its structure. Its instruments recorded bursts of radiation from debris streams as they twisted inward, some colliding at relativistic speeds. The probe's high-speed imaging caught objects visibly elongating under tidal forces before tearing apart. These recordings, transmitted across billions of kilometers, showed destruction on a scale beyond anything Earth had ever witnessed. Mountains pulled into streams of molten rock, then to vapor, then to nothing. And still, the black hole came closer. Its passage through the outer solar system had accelerated the drift of the Kuiper belt into chaos. What had once been a vast, serene halo of icy bodies was now a storm cloud, shedding objects in every direction. Even as the largest fragments fell sunward, the smaller ones filled the void with a constant haze of micrometeoroids. Spacecraft traveling beyond Mars began to report increased impacts, tiny but relentless pings against their hulls, the first spray of a much larger tide. By autumn, the consequences became visible without a telescope. Earth's orbit itself was now measurably stretched. The length of the year had shifted by nearly a second. To the untrained eye, the sun's position in the sky seemed unchanged, but ancient stone calendars, built to mark solstices with shadows, began to misalign. In some regions, equinox sunlight no longer touched the markers it had for centuries. Then came the warning that made headlines in every language on Earth. A dwarf planet, possibly once part of the Kuiper belt, was on a direct collision course with Jupiter. It was nearly 900 kilometers across, large enough that its impact would tear through Jupiter's atmosphere and release energy visible from Earth. The strike would occur in a matter of weeks, and though the gas giant posed no direct danger to Earth, the violence of the event would send gravitational ripples through the system. Governments prepared for the indirect consequences: altered cometary paths, unstable asteroid families, and perhaps even shifts in planetary resonances. For the public, it was a different kind of preparation, the dawning awareness that the black hole's approach was no longer a phenomenon to watch from a distance. It was here, its fingers already in the fabric of our world, reshaping it moment by moment. As the year closed, the eye had swollen to its largest size yet. It no longer seemed to move slowly across the sky, but to loom, a warped scar in the heavens, a curtain pulled taut across the stars. Every photograph, every night's gaze upward, was a reminder that this was the last year before the tide reached its peak. And in the deep, silent dark beyond Neptune, the black hole's final approach had already begun. The final months arrived not with a single event, but with an unbroken cascade of them. Every week, the solar system's geometry seemed to change under our feet. The ephemerides, the precise tables of planetary positions that had guided navigation for centuries, became unreliable within days of their printing. Spacecraft en route to Mars or the outer planets required near-constant trajectory corrections, their paths warped by gravitational currents no one had ever encountered in this region of space. In January, the dwarf planet bound for Jupiter finally arrived. The impact was titanic, visible even to small backyard telescopes. As the worldlet plunged into Jupiter's atmosphere, it ignited in a series of expanding shockwaves, each the size of Earth's continents. Dark scars bloomed in the giant planet's cloud tops, swirling in turbulent spirals that would take years to fade. For days afterward, astronomers tracked the shifting motions of Jupiter's moons, disturbed by the sudden redistribution of mass and momentum. The effect rippled outward. Several of the planet's Trojan asteroids, once locked safely in gravitational harmony, were jolted into unstable paths. 2 were projected to pass through the asteroid belt within months, with one having a small but real chance of intersecting Earth's orbit within the next decade. The black hole had not yet passed at its closest, and already its indirect influence was rewriting the solar system's architecture. By March, the cometary bombardment intensified into a true storm. The night sky became alive with motion, streaks of fire tearing across the atmosphere almost nightly. Some were no larger than boulders, burning away harmlessly. Others exploded with the force of nuclear weapons in the upper atmosphere, sending shockwaves across thousands of kilometers. In rural Siberia, one detonation lit the horizon like dawn and shattered windows in villages hundreds of kilometers from the blast. On the oceans, tides became unruly. The moon's orbit, now visibly perturbed, caused surges that no prediction model could match. Entire coastlines experienced flooding at times when charts promised low tide. In other regions, fishing fleets found themselves stranded in harbors as the water receded unpredictably. For the first time in living memory, the world's tidal patterns could not be reliably forecast. The atmosphere responded in kind. Jet streams split and looped back on themselves, spawning weather systems that defied normal latitude boundaries. Hurricanes spun in the South Atlantic, blizzards swept into tropical zones. The agricultural belts of multiple continents faltered as planting seasons collapsed into unpredictability. Relief convoys began to move not for war or disaster, but for simple climate displacement. Whole towns forced to relocate as their water sources vanished or their land flooded permanently. By May, the eye had grown into a yawning distortion so vast it swallowed entire constellations. In dark sky regions, its warped lensing was unmistakable. Arcs of light wrapping nearly in circles, stars appearing twice or even 3 times as their light bent along different paths. Photographers captured time-lapse footage in which the stars seemed to swirl around a fixed point, as though the entire sky were being stirred. Then, Aegis sent its last great transmission. From its forward position, now deep in the outer reaches of the black hole's tidal domain, the probe captured a view that no human had ever witnessed. The accretion halo filling half its sky, flickering with constant flares from captured debris. Background galaxies were distorted into perfect rings, their shapes looping around the central void. And in the halo itself, chaos. Fragments of worlds shredded into ribbons of plasma, spiraling into nothing. It was the final gallery of destruction before the probe's systems began to fail under the relentless gravitational gradients. Aegis went silent a week later, its signal lost forever to the abyss. June brought the first major impact on Earth from the comet storm. An object nearly 800 meters across, undetected until too late, struck the South Atlantic. The explosion vaporized cubic kilometers of seawater, sending shockwaves through the ocean that battered coastlines on 3 continents. Tsunamis climbed 20 meters high in some places, inundating ports and sweeping entire towns inland. The death toll was staggering, the economic shock incalculable, and it was only one of dozens of large bodies still inbound. In August, gravitational anomalies became visible even to the casual observer. Mars and Venus shifted in the night sky against their usual backdrops, moving just enough over weeks that amateur astronomers noticed without equipment. Space agencies confirmed that the entire inner solar system was now caught in a slow but accelerating rearrangement. Earth's orbit had stretched into a slightly more eccentric ellipse, increasing seasonal extremes. Summer was hotter, winter colder, and both came at the wrong times. By October, the noise of incoming comets became so constant that impact alerts blended into the background of daily life. Cities practiced shelter drills, rural communities built bunkers. Interceptor launches flared across the skies of multiple continents every few days. The night was no longer quiet, the heavens were alive with fire. And, looming ever larger, the black hole approached. It was not a star, not a comet, not an asteroid. It offered no light of its own. Yet it dominated the sky like a wound in the fabric of reality, pulling everything into its slow, inevitable tide. The final weeks had begun, and the solar system itself was reshaping before our eyes.
The last days came with a strange, oppressive quiet. Not the absence of sound, but the absence of normalcy, the silence of a world holding its breath. The sky itself seemed altered. Even by day, the sun's position felt subtly wrong, its arc through the sky not quite matching the instincts of a lifetime. At night, the constellations were grotesquely warped, the eye having swollen to a distortion so vast that it devoured nearly a quarter of the heavens. Entire star fields curved and doubled on themselves. The black hole's presence was no longer an abstract calculation, it was visible, physical, undeniable. In the observatories, the numbers tightened until there was no room for doubt. The black hole would pass just beyond the orbit of Saturn. That distance, unimaginably close in cosmic terms, was far enough to spare the sun from direct disruption, but close enough to send tidal forces screaming through the solar system. It would be the single most violent gravitational encounter in the history of human civilization. The approach accelerated everything. Jupiter, already deflected by the black hole's pull, shifted enough to scatter dozens of its outer moons into unstable orbits. Several small moons collided with one another, their impact sending plumes of debris into space. Saturn's rings shredded into spiraling ribbons as tidal stresses exceeded the bonds holding their icy particles in place. Neptune's orbit compressed further, its faint arcs of methane clouds whipping into fierce storms visible even from Earth. And then the comets came all at once. It was as if the black hole's arrival had flung open a gate. In the span of 2 days, a dozen major bodies crossed into the inner solar system. Planetary defense networks intercepted some, others broke apart naturally, their fragments raining down as fiery streaks. But one, a 2-kilometer mass of ice and rock, slipped through entirely. It struck the Arctic Ocean north of Siberia, sending a wall of water racing southward. Coastal cities from Murmansk to Tromsø vanished under waves that carried icebergs the size of office towers. On Earth's surface, strange tides surged without warning. Water climbed far higher than predicted in some places, vanished entirely from shorelines in others. Rivers reversed flow temporarily. The moon's orbit was in chaos now, no longer a clean ellipse, but a trembling loop tugged in 2 directions, one by Earth, the other by the black hole's immense and passing grip. And still, the gravitational waves built. Detectors across the globe howled with low rising hums as space-time itself flexed in response to the intruder's passing. The signals were strong enough now that they could be converted into audible tones, a deep, rising note like the groan of some colossal machine, felt as much as heard. In the final 24 hours, the black hole's tidal reach wrapped fully around the inner planets. Earth's orbit elongated further, pulling the planet slightly farther from the sun. The change was small, fractions of a percent, but enough to alter the balance of seasons forever. Venus's clouds twisted into strange planetary-scale vortices. Mars experienced quakes as tidal forces flexed its crust,
dust storms erupting across the entire planet. And then came the moment. Closest approach. The black hole swept past the outer solar system like an invisible scythe, its gravity stretching the space around it into a warped, flowing funnel. From Earth, it could not be seen in the ordinary sense, but its lensing effect was overwhelming, an immense halo of bent starlight shimmering against the black, arcs of light flowing around nothing. The event horizon itself remained perfectly dark, a hole in the world from which no color, no glimmer, no hint of matter escaped. For hours, the entire solar system vibrated with the encounter. Moons shifted their courses permanently. Comets and asteroids were flung into new, chaotic paths. Some would take centuries to return. Others would be lost forever into interstellar space. The black hole passed indifferent, its path already carrying it away, its work, if it could be called that, complete. When the tide began to recede, the changes it had left behind were irreversible. The planets would never return to their exact old orbits. The Oort cloud had been permanently disturbed, ensuring an elevated rate of cometary bombardment for thousands of years. The length of Earth's year was altered, the timing of its seasons forever shifted. But for all the destruction, for all the violence of those days, the world still turned. The sun still rose. Humanity, battered but alive, looked to the night sky and saw the eye shrinking as the black hole drifted outward into the dark, the greatest danger it had ever faced now receding into the unknowable distance. The silence that followed was not relief. It was something deeper, the stunned awareness of having witnessed a thing far older, far more powerful than ourselves, and having survived it.
In the weeks after the black hole's passing, the sky looked wrong in ways that no one could quite articulate. The constellations were still there, but their geometry had shifted, subtly in some places, dramatically in others. Planets rose at unexpected times, their paths skewed from the patterns human eyes had known for millennia. The eye was gone, receding into the black like a wound that had closed, but the sky bore its scar. Faint, permanent distortions in the positions of distant stars, the residual signature of space-time that had been bent to its breaking point. The first priority was survival. Whole coastlines lay in ruin from the comet impacts and tidal surges of the final months. Supply chains were fractured. Food production had collapsed in regions where seasons no longer aligned with agricultural cycles. Relief ships and aircraft crisscrossed the globe, their missions aided by an unprecedented level of cooperation between nations. Not out of goodwill, but necessity. The threat had been universal, and so was the aftermath. The moon's orbit was the most visible change. It now followed a slightly wider, more eccentric path around Earth, altering the tides in ways that would take generations to fully predict. Some harbors found themselves permanently stranded above the waterline at low tide, while others were inundated with each lunar cycle. Entire port cities began the long process of redesigning their infrastructure, building to meet a new rhythm dictated not by the moon as it once was, but by the moon as it had been reshaped. Climate scientists faced a planet whose year was measurably longer. Its orbit stretched into a subtle ellipse. Seasons became more extreme, with scorching summers and deep winters, each arriving days or weeks later than their historical averages. The planting and harvesting calendars that had underpinned agriculture since the dawn of civilization were obsolete. New ones would be written from scratch, aligned to a world that no longer matched its own history. For the astronomers and physicists, the black hole's departure was not an ending, but the beginning of an era of unparalleled discovery. Aegis, lost to the void,
had sent back data so detailed it would occupy generations of researchers. Entire models of general relativity would be rewritten to account for phenomena observed up close for the first time. Gravitational wave archives from the encounter contained information not just about the black hole itself, but about the deep structure of space-time in our own neighborhood of the galaxy. And yet there was an unease beneath the scientific triumph. The Oort cloud had been steered into chaos. Even conservative models predicted centuries of elevated cometary activity. Humanity would live under a sky with a higher statistical chance of extinction-level impacts for the rest of its existence. Planetary defense, once a niche field, became the backbone of global security. Space agencies merged or formed permanent alliances, their mission no longer exploration for its own sake, but watchfulness. In the decades that followed, a generation grew up that had never known the steady, unchanging solar system their parents had taken for granted. To them, the warped constellations and erratic seasons were simply the way the world was. And in their art, music, and language, the memory of the eye persisted, sometimes as a symbol of terror, sometimes as one of unity. For there had been unity, however brief. In the face of an indestructible, indifferent force, humanity had looked upward together. The black hole had not cared if we fought or cooperated, prayed or cursed, measured or imagined. But we had chosen to meet it with both fear and curiosity, to study it even as we braced for its worst. We sent a machine into its shadow and pulled knowledge from its grasp. We endured. Centuries from now, when the black hole's path has carried it so far that its lensing vanishes entirely and the constellations stabilize into their new geometry, our descendants will still see the marks it left in the tilt of orbits, in the rhythm of tides, and in the cold data etched into the archives of science. And perhaps, in the quiet of some distant observatory, a young astronomer will look out into the black, trace the path backward, and whisper to themselves of the time when a wound in the sky came close enough to touch the world. We survived the tide, but the ocean it came from, the deep, dark sea of the universe, is still out there, and in it, other shadows are moving.